I was asked a question about solving trig equations, and when you're given an interval, how do you know how many times to go around and what to choose? So I chose this, sine x plus sine 2x equals 0. X, that angle, has to be between 0 and 2 pi. You include 0, you exclude 2 pi. That's really one time around the circle. Let me put this back up. Gosh, I do that every time, don't I? Let's see here, just a second. Okay, let's try this again. So, one time around the circle is what that's really saying. X would be one time around this circle. Boy, got to practice that some more. Now, the way you solve these, if you've got a mix of arguments, these angles are mixed here. One is just x, one is 2x. You can't solve your equation very easily, at least, when you have these mixed arguments. So you change it into the same. Either make this a 2x or make that an x, and it's easier to make this a 2x, not a, the 2x into an x. What is the double angle for this? And that's why we learn these identities. It's 2 sine x cosine x, and that equals 0. Now, when you've got something equal to 0 and you've got more than one trig function, then you should look to try and factor it out so that the factors only have one trig function. So if I factor out a sine x, I'm left with a 1 plus 2 cosine x. And that factorization has put into each of these factors just one trig function. Now you can do like you did in college algebra or algebra 2 and said, let's set that sine x equal to 0 because one of these, sine x equal to 0, either that's got to be 0 or the 1 plus 2 cosine x has got to be 0. That's the only way. This is the zero multiplication property. So if sine x is 0, then we've only got one spot here. Where's the only place where the sine is 0? Oh my goodness. One time around the circle. Well, it's here at 0, right? And because we've got 2 pi here, we know we're using not degrees, but radians. So it's 0 radians for the answer for this one. That's only one place there. Here, you have to start solving for the cosine. So 2 cosine x is equal to a negative 1. And cosine x is equal to a negative 1/2. So now, let's use this one up here. This is really for the cosine, and the cosine is negative in the second and third quadrants. Remember, all seniors take Cal 4. So all of them are positive here. Just the sine and cosecant are positive here. The tangent and cotangent positive here. The cosine and secant positive here. So where's the cosine negative? It's in the second and the third. Now, if the cosine is equal to a negative 1/2, then this is the negative 1, and the 2's got to be the hypotenuse for both of these. This is as easy as 1, 2 square root of 3. So this is a positive square root of 3, and this is a negative square root of 3. So, well, what does that tell me? This is really a 30, 60, 90 right triangle. These reference angles here are 60 degrees. That means that we've got this angle, which is 120 for one choice, and this angle, which is another 60 past 180, and 180 and 60 is 240. Well, we need to have this in radians, though. Oh my gosh. 120 degrees in radians is 2 pi over 3. That's 2 pi over 3's, which is 2 60s, right? This is a 3 of 4 pi over 3. So I'm going to get rid of this. Call this 4 pi over 3. Now that's one time around the circle because we're just using x. And x goes from 0 to 2 pi. You can go up 2, but do not include 2 pi. So our solutions for x would be the 0 radians from this first part, it would be these other two, and you usually look for two, except when you hit a quadrantal angle like this sine. Then, so let's see, 0 radians. Now from here we get the 2 pi over 3 radians and the 4 pi over 3 radians. And that's going around once. Expect 2 if you only get 1 because it's a quadrantal angle. That's fine. So that's good, but what happens when you have multiple angles? Well, let's clear the screen here. Suppose we have just, let's make it sort of easy, the sine of 2x is equal to 1/2. Now you might say, well, heck, I'll just use the double angle formula to sine x cosine x, except this is equal to 1/2. This is not equal to 0. You want zeros when you factor 0 on one side and everything else on the other side. You could try to, I guess, write that as the sine of 2x minus 1/2 equals 0. But then what do you factor? Well, you can write this as 2 sine x, cosine x minus 1/2. But what do you factor? There's not a nice factorization here. You don't have something in both of these. I guess you could factor out a 1/2, but that doesn't help you with this sine times cosine stuff. So that method doesn't work. But what's nice is you don't have to get it down to x. You can just say, okay, sine 2x is 1/2. Let me solve it for 2x. The big difference here is that coefficient tells you how many times you've got to go around the circle. Okay, so where's the sign positive? Don't worry about the 2x yet. Just say, where's the sign positive? It's positive in the first and the second quadrants. And if the sine is 1/2, that's opposite over hypotenuse. This is still a positive 1 over 2 over here. But now we get, this is easy as 1, 2 square root of 3. This is a positive square root of 3 for the x and a negative square root of 3 for the x. But all you really need is this reference angle. This is still, well, I guess it's not still. This is now a 30-degree angle for a reference angle, or pi over 6. So you're going to go around this. You're going to say, okay, this is pi over 6. This is 1, 2, 3 pi over 6 is pi over 2. 4, 5 pi over 6 is when I'm pi over 6 before pi, because that's 6 pi over 6. 7, there's an 8 pi, oh, no. But that's not when the sign is positive, that's when it's negative. So you don't use these two reference angles, pi over 6. But now that you've got this 2x instead of x, you go around the circle twice. So you come around and you hit the 2 pi, which is, of course, how many pi over 6s? That's 12 pi over 6, right? One more pi over 6, and you get to 13 pi over 6. And, or if you just add 2 pi to these numbers. 2 pi, which is 12 pi over 6, and 5 pi over 6. 12 and 5 is 17 pi over 6s. And all four of those will be written for 2x. Let's see, we've got the pi over 6. We've got the 5 pi over 6. We've got the 13 pi over 6. And we've got the 17 pi over 6. Now we've got 4 of them because we run around the circle twice. But those aren't the answers. That's the answer for 2x. We want, and I'll have to write it again here, x in the interval from 0 to 2 pi. Not including, not above, not 13 pi over 6. That's too big. 17 pi over 6. But of course this is for 2x. So if we multiply both sides by 1/2, this whole thing by 1/2, we get x is pi over 12. And 5 pi over 12. And 13 pi over 12. And 17 pi over 12. And if you look at that, the 17 pi over 12, remember 2 pi is 12 pi over 6, or how many pi over 12s? 24 pi over 12s. So I didn't make it to that 2 pi yet. 17 pi over 12 is still within that once around the circle, x between 0 and 2 pi. These 4 answers are for x. I hope that answers your questions. We'll see you later on. Bye.